Good morning all. So in today's class we will be going on to the second module. So in second module we will mainly look at the power series solution of given differential equation. So in the second module we'll begin with a few preliminaries of power series. So what do we mean by the convergence of power series, then how to find the radius of convergence of power series. So we'll see all those in the beginning, and then we'll move on to finding the series solution for differential equations of first order, and followed by the series solution for differential equations of second order. And then we'll be seeing what are called ordinary points, then regular singular points, and we'll freshen up what you have learned in the your degree classes. I think we have learned the Frobenius method. So we'll see all those regular singular points, then method of Frobenius, and then towards the end of the module we will see what are called the Gauss hypergeometric functions, then how to solve the associated differential equation to that. Okay. So we'll look at how to solve for the Gauss hypergeometric equation. So that's what we'll be mainly doing in the second module. So in today's class we will see a few basic things regarding the power series. So we'll just go back to the definition of power series. What do we mean by the convergence, and few tests for finding the radius of convergence and all, and we will see a few associated problems. Okay. So let us begin with power series. Now an infinite series of the form summation n equal to 0 to infinity an x raised to n, so that is a naught plus a1x plus a2 x square plus etc. This is called a power series in x. So this infinite sum is called a power series in x, or this is a power series which is centered at the origin. Now similarly you can have power series centered at a different point. So if you have a series of the form summation n equal to 0 to infinity an x minus x naught whole raised to n, so that will have the expansion a naught plus a1 x minus x naught plus a2 x minus x naught whole square plus etc. So this is a power series in x minus x naught. So this is a power series which is centered at the point x naught. So this is how we define a power series. So that can be centered about the origin. So it can be in powers of x, or it can be in powers of x minus x naught. Now a power series is said to converge if this sum is a finite value. So if the sum is equal to a finite real number, we say that the power series converges. So therefore the series, so let us look at the first series. So the series summation n equal to 0 to infinity an x raised to n is said to converge at a point x. So you have studied that a series will converge if its sequence of partial sum converges. So in that context So this series is said to converge at the point x if the limit m tends to infinity, summation n equal to 0 to m an x raised to n exists. So this is limit m tends to infinity. So this is Sm. So if the sequence of partial sum, so if Sm converges, so you say that the series converges, and the value we get, or the value of this limit, is called the sum of the series. So if the limit exists and it is called the sum of the series. So that is how we define the convergence of the series. And again, when you have a series of the form summation n equal to 0 to infinity an x raised to n, it will always converge at the point x equal to 0. So when x is 0, the sum is going to be a0. അപ്പോൾ നമ്മൾ ആദ്യത്തെ സീരീസ് summation n equal to 0 to infinity an x raised to n, that will always converge at x0. ഇനി രണ്ടാമത്തെ സീരീസ് n equal to 0 to infinity an x minus x0 whole raised to n, it will always converge at x equal to x0, and in that case also sum will be equal to a0. So every series will definitely converge at its center, then it can converge at many other points also. That depends on the series. So the series summation n equal to 0 to infinity an x raised to n always converges at x equal to 0. And every series can be classified into 3 types. So the first type of series is series which diverges at all points except at namala ee particular with respect to this series anengil. So there are 3 type of series, so which converges only at x equal to 0, then it converges in an interval of the form minus infinity to infinity, then it can converge in the interval of the form minus r to r. So these are the 3 types of behavior for any series. So in the first type, your series converges only at a single point and it will diverge at all the other points. So in that case, your radius of convergence will be equal to 0. In the second case, your series will converge for all the x values. So here the radius is going to be equal to infinity, and here your series will converge in an interval. So series is centered at 0, so it will converge in an interval of the form minus r to r. So the interval has a radius r. So here the radius will be equal to r. So these are the 3 behavior for any series. So this number is called the radius of convergence. And for finding the radius of convergence, we typically use the ratio test. So the ratio test states that, so if you have a series summation n equal to 0 to infinity un, so when you find limit n tends to infinity mod un plus 1 by un, so suppose the limit be equal to L. So if L is less than 1, then the series converges in that case, and when L is greater than 1, the series diverges. So that is the ratio test for convergence. So when it applies upon the series summation n equal to infinity, n equal to 0 to infinity, an x raised to n, limit edukumbo, you will get limit n tends to infinity. The n plus 1 term is an plus 1 x raised to n plus 1 by an x raised to n. So that is equal to limit n tends to infinity mod an plus 1 by an into mod x. So that will be equal to L. So if L less than 1, the series converges, and if L greater than 1, series diverges. So therefore from here we will get the radius of convergence to be so therefore the series will converge if mod x is less than limit n tends to infinity mod an by an plus 1. So that is mod x is less than r. So here r will be equal to limit n tends to infinity mod an by an plus 1. So therefore the radius of convergence will be equal to, so that will be limit n tends to infinity mod an by an plus 1 by the ratio test. And the interval of convergence will be given by, so interval of convergence will be is minus r less than x less than r. Now at the endpoints, so at the endpoint series may converge or diverge. So at endpoints series may converge or diverge. So that depends on the series. So for that you need to substitute your endpoints in the given series and check for whether it converges or diverges. So when you say that the interval of convergence is minus r to r, the series converges. So inside minus r to r and diverges outside the interval. So at the endpoints it may converge or diverge. That varies from series to series. And again we can define the derivatives of the series and then their integrals. We can define the sum of the series, difference of the series, then we can define the constant multiple of the series and product of the series, so on. So in each case you can find the corresponding radius and intervals of convergence. So with this we will wind up for today. So we will see, we will continue in the preliminaries in the next session. Thank you.